Hello third year students and welcome to my channel. Also welcome to this video. I hope you had a wonderful holiday. If you did not, you can try again in October. Anyways, in this video, I want to create a picture, a clear construction. I want to show you all what the big difference is between mathematics in the second year and mathematics in the third year. And we are going to do this together. So please grab already your notebook and a pen or pencil. And this shirt that I'm wearing, it displays Pythagoras. I'm going to show you the difference between the 2 years using indeed Pythagoras and calculating with square roots. So let's start. So we will look at two subjects from the second year. Well, one of them is multiplying. You can write with me in your notebook. Multiplying square roots. That's something you did, I think it was chapter 4 previous year, second year. And we're going to look at the Pythagoras theorem. Pythagoras theorem, which was a subject in chapter 5, also second year. Now, it doesn't matter if you do havo or VWO, they were both subjects. Now, this is all second year. What we're going to do now, I'm going to show you what is actually the third year. Why is it why is it more difficult than the second year? Well, now in this video, we're going to combine these two to show you what a third year exercise could look like. Using what you know from your second year. Yeah. So what we're going to do, let's immediately start on this exercise. Yeah. So if I'm going too fast, please just pause the video so you can work with me. We're drawing a right angle triangle. And why are we drawing this right angle triangle? It is because Pythagoras theorem can only be used in right angle triangles. Now, you're very familiar with this. You have the adjacent side, the other adjacent side, and you're looking for the hypotenuse, for example. So we're putting a question mark here, and then I'm going to divide the two different levels. So for havo, you'll be working with, this is, for example, the square root of 6, and this measurement is the square root of 3. And VWO, so this is also havo. VWO, you will be working with other numbers. I'm going to give you, this is the measurement is the 2 square root of 6, and this measurement over here is for VWO. Let me just think of something. Let's say it is have to come up on something, but 3 square root 3. So let's see how that turns out. So just two different measurements for the different levels. All right, so now you can see it's already a bit more difficult. These are not just numbers like you were used to. You were used to see easy numbers for the adjacent side, and then you could calculate this one. So you already see, okay, I'm working here with square roots. Now, mind you, I have a calculator here with me, but we are not going to use it, at least not until the end. Now, this is already Pythagoras theorem inserted here, and you can see, okay, we're going to do something with square roots. Now, you remember, I hope, Pythagoras theorem. Just once again, what was it again? If this is A, this is B, this is C. Pythagoras theorem said A squared plus B squared is C squared. Now, we always write down the Pythagoras theorem for a triangle. Now, this one doesn't have a name, so just work with me with the numbers. So, let's write it down for the havo levels. A is the square root of 3. We're going to write it here. I just want you to pause the video so you can write it down yourself. Please pause so you can actually, write this down all on your own. This is the square root of 3, but it has to be squared. So what we do is this number we put between brackets squared. So you can already see where this subject is inserted. Then we write there b, which is square root of 6 squared, which is going to give us, of course, c squared, which is not yet c, but it's c squared, you know, the big square we used to draw here. Now, for VWO, please pause the video and do it yourself. It is 2 square root of 6 squared plus 3 square root of 3 squared. Don't forget your brackets here. It's super important. You're going to see later why. Now, this is your moment. Pause the video and let's see if you still have chapter 4 from the second year in you. So you can calculate this. You don't need a calculator. Do not use calculator. This is this. If you know your rules, then you remember that we practiced that the square root of a to the power of 2, yeah, is just a, yeah. So I hope you remember the square root of 3 times the square root of 3 makes 3. The square root of 6 times the square root of 6, yeah, so it's times itself. Hey, that makes 6. So this is just 3 plus 6 is 9. I am super sorry for writing it in one sentence, but please bear with me. It's 9, and that is equal to c squared. So what is eventually c? Yeah, we're going to write it down here. C square is 9, so c is the square root of 9, which is 3. And for VWO, once again, without a calculator, 2 to the power of 2 makes 4. Square root 6 times itself is 6. So we write, of course, there's a multiplication sign in the middle here that we don't see. And then here again, 3 to the power of 2 makes 9. And this becomes 3. Eventually, you get 24 plus 27. Now, this is the moment where you can grab your calculator. But this makes then 51. My bad, guys. Yeah, this is a perfect grab your calculator situation, but we can do it mentally. 51. So over here we get that c squared is 51. So c makes the square root of 51. Now, I don't know that one out like mentally, you know, so I'm grabbing the calculator. The square root of 51 gives us about 7.1414. Remember the writing with the dots. This has to be, by the way, equal sign because here we are rounding. Let's say we round to 2 decimals. We say this is 7.14. So now you can see Pythagoras theorem combined with multiplying square roots. Now, if you understand this, that's perfect, guys. Make sure that you write along and that you wrote along because these are good notes that you can always look back. Now, stay a little bit longer if you want to know. I'm going to explain this part a little bit more. So I'll go over here. For the students that find this still difficult, let's just look back at the basics. So, for example, you had exercises like 2 squared 6 to the power of 2 plus 5 and then squared 7. Let's take this one to the power of 2. Now, if it's inside the brackets, you also multiply it times itself. So you know, okay, 2 times itself, so 2 times 2 makes 4. Then you know, okay, the square root of 6, I'm writing it like this. The square root of 6 times the square root of 6 is using what you know. 6 times 6 makes 36, so square root 36. But this is equal to 6. So that's why we actually forget about the middle part and immediately just say, if I multiply a square root by itself, it becomes a number underneath the square root. That's why we write down 6. So this is 4 times 6. Now, if you remember, if it's not inside the brackets, it stays 5. But then, once again, you see here, hey, this is inside the bracket. Okay, I'll multiply it times itself. eventually it becomes 7. If you don't believe me, you can do it in like intermediate steps. Square root 7 times square root 7 makes square root of 49, which is indeed 7. And then, of course, you use your order of operations. You get 24 plus 35, which will give you 59. All right, guys. So I hope you got a little bit of a a clear view what is actually the third year, what is expected from you. And what is expected is that you can combine multiple subjects that you learned all together in one exercise. So how would a test exercise look like? Let's see on the test.